This is section 4.4, part 2. We're still talking about the trig functions at any angle, and today we're focusing on objective 2 in that section. Now, objective 2 is using the different signs of the trig functions. Now, by signs, I mean their positive or negativity. Let's quick review a few of our trig functions. Remember that the sine of theta is equal to the y value, the cosine of theta is equal to the x value, and the tangent of theta is equal to y over x. And that's just a review. And then we also have all of their reciprocals. Now let's go ahead and use those to help me determine quadrant 1. In quadrant 1, both the x value and the y value are positive. That tells me that both sine and cosine in quadrant 1 are positive, along with tangent, because tangent will be a positive divided by a positive, which is also positive. So all of our trig functions are positive in quadrant 1. Now let's look at quadrant 2. In quadrant 2, the x value is negative. That means that cosine and secant are going to be negative. Now, the y value in that quadrant is positive. So if I divide a positive by a negative, I get a negative answer. That tells me that tangent and cotangent are also negative in quadrant 2. So what about the positives? Well, that would be the y value, which is sine, and its reciprocal, cosecant. Let's go down to quadrant 3. In quadrant 3, both the x and the y are negative. So that tells me both sine, cosine, and their reciprocals, cosecant and secant, are all negative. But what happens when we find tangent? When we divide a negative divided by a negative, we get a positive. So that means that tangent and cotangent are positive in that quadrant. And finally, I hope you're seeing a pattern here. In quadrant 4, the x value is positive. So that tells me that cosine and secant are both positive in that quadrant. And then all the rest, sine, cosine, cosecant, tangent, and cotangent are all negative. Now, I do have a couple memory tricks that you can use, well, one specifically to help you remember these. I like to look at the 4 quadrants, and I use the trick that all students take calculus. And this is telling me the positives. So you can see they're all positive in quadrant 1. Sine is positive in quadrant 2. Tangent in quadrant 3, and cosine in quadrant 4. So all students take calculus, and that's just the memory trick that I use. There's lots of others you could come up with on your own. So let's now see how we can use these rules to help us decide where different angles are at based on their signs. So here's our first example. Tangent of theta is less than 0. Now that means the 0 is bigger. The alligator is eating the 0. So that means tangent is positive. And cosine, and I'm sorry, that means tangent's negative. Try again. And cosine of theta is bigger than 0. So that means that cosine is positive. And we want to know where the angle is. So let's think for a minute. If we use that memory trick. First off, cosine is positive. So right now, that takes out quadrants 2 and 3 because cosine is negative in those quadrants. Now, since tangent is negative, that also takes out quadrant 1, so the answer must be quadrant 4. Theta would be in quadrant 4. Let's look at the next one. Sine is less than 0, that means sine is negative, and so is cosine, and we want to know which quadrant it's in. So once again, I'm going to use my little memory trick to help me here. Now, we know that quadrant 1 is out because neither are positive, and also quadrants 2 and 4 because that's where sine and cosine are positive. So that means we must be in quadrant 3. I want you to go ahead and do the same thing for your free response question. I want to know the quadrant theta is in if sine is less than 0 and tangent is less than 0. Once you're done with that question, you can go on to the next slide. Now, in this slide, we're given the tangent of theta is negative 2/3. And we're given that cosine is greater than 0. And we want to find cosine of theta and cosecant of theta, the exact values of those. So let's first start with a picture here. Now, before we draw our picture, we need to decide what quadrant is this angle in. So we need to look at our given information. Now in this case, we're told that tangent is negative 2/3. That means tangent is negative and cosine is greater than 0, so cosine is positive. So we need to look and decide where is tangent negative and cosine positive. And the two quadrants that cosine are positive in is 1 and 4. And since tangent is negative, that means that we have to be in quadrant 4. So now we'll go down here and we'll draw our angle, our theta, in quadrant 4. So here will be our triangle that we're going to use to help us. Now, tangent is equivalent to the opposite over the adjacent. So we're going to put the 2 here and the 3 here, opposite and adjacent. And it's important to think about the negative. Now in this case, where would the negative go? With the 2 or with the 3? I hope you're thinking that the negative should go with the 2 because the y value is the negative 1 here. The other thing we need to do is find the radius or the hypotenuse of this triangle. So we're going to use the Pythagorean theorem and say 3 squared plus negative 2 squared equals our radius or our hypotenuse squared or c squared. You could call it whatever you want. So 9 plus 4, so we get 13 is our radius squared. And that means that our radius here, or the hypotenuse of this triangle, is the square root of 13. Now that we have our triangle all filled in, we can go ahead and answer this question. We're looking for the cosine of theta and the cosecant of theta. Now, cosine is going to be adjacent over hypotenuse. So we would get 3 over the square root of 13. And don't forget to rationalize your denominator. And the answer becomes 3 root 13 over 13. And hopefully we're getting pretty good at rationalizing those denominators. Now, cosecant is the reciprocal of sine. So you could find sine and then take the reciprocal. Remember in terms of SOHCAHTOA that sine is opposite over hypotenuse. So that means that cosecant will be the hypotenuse over the opposite. So we would get negative root 13 over 2. And you could have the 2 in the top or in the front. We don't like to put it with the denominator though. And so those would be our two solutions there. Notice the first thing we did is drew the picture, and we had to use the signs that were given to determine what quadrant our triangle was in. Our last example for the video, we're given that the tangent of theta is 3/5 and cosine is less than 0, and we want to find sine and secant. So the first thing here to determine is what quadrant our angle is in, so we can draw our angle. Now in this case, tangent is positive and cosine is less than 0, so cosine is negative. So we need to think about which quadrant tangent is positive in and cosine is negative in. And the only two quadrants tangent is positive in is 1 and 3, and quadrant 1 is out because that will be where they're all positive. So it looks like we're now in quadrant 3. So let's go ahead and draw this picture of our triangle. And once again, our triangle is going to be here in quadrant 3. And our theta would be inside here. Now tangent again is opposite over adjacent, so 3, 5. And we need to go ahead and use the Pythagorean theorem once again. So we'll say 3 squared plus 5 squared equals our radius squared. Now before I go on, there's one thing we need to think about for a minute here. In quadrant 3, both the 3 and the 5 should be negative because we're going back on the x-axis and down on the y-axis. Now in terms of our Pythagorean theorem, that's not going to change anything here to put those negatives in, because when we square them, we're still going to get our positives. But it's important to know that when we start finding the rest of the trig functions. When I add those together, I get 34 for my radius, and when I square both sides, it looks like I get the square root of 34. Now that my triangle's all filled in, I can find the sine of theta and the secant of theta. Sine is opposite over hypotenuse, so we get negative 3 over the square root of 34. And we want to make sure that we rationalize the denominator there, so we get negative 3 root 34 over 34. Now in terms of secant, secant is the reciprocal of cosine. You could find cosine. Remember, cosine is adjacent over hypotenuse, or you could just take the reciprocal of that and do hypotenuse over adjacent, and we'll get negative root 34 over 5. For our answer. Now, had you forgotten these negatives here with the 3 and the 5, notice that your answers would have been positive, so you would have been incorrect. We need to remember to make those negative. You could just leave them positive and find your answer, and then at the end, remember to switch it and make it negative. Right now, I want you to try this multiple choice question on your Google form, and this is where our video will end for today. You're given the cotangent of theta, and also that cosine is less than 0, and I want you to find the cosecant of theta. So you'll go through the similar process that we just went through in the previous two examples, and we'll start class with these tomorrow.